Hello and welcome back to the fourth video in our series on Southwire MC-AP cable. My name is Dave Watson. I'm a Principal Applications and Consulting Engineer with Southwire. I'm heavily involved in the Applications Engineering team and with our codes and standards work. I'm currently on 2 NEC code-making panels and involved with a number of other standards technical panels involving UL, CSA, and other organizations. Now, there are 4 short videos in this series, and as I mentioned earlier, this is the 4th in the series, the last one. The first video is an introduction to AC and MC and MC-AP cables. So this gives you the history, if you will, the background information for all of these products. A short description of what the pros and cons are for those products. The second video is a deeper dive into the performance of MC-AP cable, especially in regards to grounding. The third video is of primary interest to the installers and the inspectors out there. This video focuses on the NEC and UL references and also on the installation of the product and the differences between those. So let's get into the 4th video. First product we're going to take a look at is our MC-AP HCF cable, which is our special construction for healthcare facilities. Now, just like type AC cable was superseded by type MC cable and then ultimately by type MC-AP cable, there's also a healthcare variant version of type AC cable. And now that product has been superseded by our MC-AP version of that product. This product meets the requirements of Article 250 and Article 330 in the NEC regarding grounding and regarding the construction of MC cable. But in addition, it also satisfies the requirements of NEC Article 517, which covers healthcare facilities, and more specifically in Section 517.13. It requires separate and redundant grounding paths to protect patients from stray electrical currents. So, NEC 517.13a requires that the outer metal sheath or sheath assembly shall itself qualify as an equipment grounding return path. And we have that on the MC-AP product. We actually have a full-size bare aluminum equipment grounding conductor that's in constant contact with the armor. So the combination of those two acts as your equipment grounding conductor. In addition, this product also has an added green insulated copper equipment grounding conductor. So a redundant grounding conductor. That's going to comply with NEC 517.13b. And now let's take a look at that product. This is our Southwire HCF MC-AP product. This is the one that is focused on healthcare facility installations. So this is based on our MC-AP construction, which means that we have a full-size aluminum bare equipment grounding conductor. In addition, we have the phase and neutral conductors, and then we have the redundant insulated equipment grounding conductor. Now, to install this product, we'll need to remove the Mylar tape. And then on this bare aluminum equipment grounding conductor, fold it back approximately 120 degrees, and then we will cut it off flush with the armor. Then we will install it on a fitting that's MCI-A rating. This is one of these snap-on type adapters, and there you go. In this slide, we're taking a look at the construction differences between HCF AC versus MC-AP HCF cable. On the left, you can see the AC version of this product. You'll notice that each of the conductors is surrounded by paper, and then you are required to use the red anti-short bushing in between the armor and the conductors. With this construction, there is a 16 gauge bond wire that must be routed back over the armor, wrapped around it several times before the fitting is applied to it. And we'll show this in more detail in the video in a moment. Let's contrast that to the HCF MCAP cable that does not have the paper wraps over the conductors. It does have a mylar wrap that covers all of the conductors except for the bare aluminum equipment grounding conductor. That bare aluminum conductor is cut off even with the armor. It is not taken into the box and terminated. Again, with this healthcare variant of the product, we do have the green insulated equipment grounding conductor also. So the combination of both of those equipment grounding conductors will satisfy the redundant requirements of the NEC. The tables on the right show you how much better the grounding is when you compare the HCF MCAP product to the older HCF AC cable. So for 12 gauge products, you'll see that the grounding of the HCF MCAP cable is over 350% better than that of the AC version. And likewise on the 10 gauge cable, you're going to see over 500% improvement in grounding. So what are the benefits of the MCAP HCF? Well, like we've just said, much better ground path. You have a full-size equipment grounding conductor, and so the combination of that plus the armor is going to be equivalent or actually better than the copper equipment grounding conductor that's used in regular style MC cable. There's no conductor limit on this product, which means we can make it in a lot of different construction variations. For example, in a moment we'll be talking about the MC-PCS product for combinations of power and control and signal. We can make that product for healthcare facilities as well. We can make this with a jacket on it for wet locations. We can do multi-circuit variations on this. So there's a lot of places that we can take this. So no conductor limit, and this is also easier to install than an HCF AC cable. Therefore, there's going to be fewer variations in the installation, should be more reliable. The anti-short bushings are typically shipped with the product, but they're not required by the NEC, nor are they required by UL. So you don't have to use those. There is in regards to the speed of installation, there's a single mylar tape covering rather than the individually paper wrapped conductors. So to make that whole process faster. And since there is more speed involved with installing this product, because there's fewer terminations in the box, there will be an increase in productivity in using this. So if you take a look at a large project, let's say you're doing a large hospital, and if you can save 1.5 minutes per run, then as you can see in this slide, it adds up to quite a bit of savings when you compare this product to others. The 5 steps of installation for this product. Step 1 is removing the armor. This shows a tool called a rotosplit, which is a very handy tool to use for removing the armor. Steps 2 and 3 are to separate and then terminate the aluminum grounding conductor. So you separate that from the other conductors in the cable, and then you cut it off flush with the armor. You do not wrap it back around the armor like you would do with a type AC cable. This is a critical step. So cut it off flush with the armor. Step 4 is to install the fitting to the box with the snap fit fittings. That's as simple as just simply pushing it in and snapping it into place very fast. Then step 5 is to ground the wiring devices. So you may need to install a pigtail from the device over to the box for proper bonding. Now we'll take a look at our MC-PCS Duo cable, which supplies both power and control signals. This cable does so under one armor. So those of you who've been working in the industry for some time may think that you can't do that, but you can in fact do that. But there are a couple of specific rules within the NEC that you need to comply with in order to be able to do this. So this product is constructed in the same way as our MCAP cable, but we have one change. We have the addition of a jacketed pair of 16 gauge TFN control and signal conductors. Now this product is fully compliant with the 2020 NEC. If you take a look at section 300.3C1, when you combine conductors like this, they all need to be rated the same. They all need to be have the minimum rating that's required to conduct the power. In this situation, we are using 600 volt rated THHN or XHHW conductors for power. So the control conductors in our PCS Duo cable are also rated at 600 volts. Now this is different from Class 2 or Class 3 cables that are going to be rated at 150 or 300 volts. So this is something a little different. So we satisfy that requirement that all conductors have to be rated 600 volts. Then there's another requirement. If you look at section 725.136 I1 and 2, those require a 30 mil PVC jacket between the power and the control signal conductors. Well, they require separation, I should say, of those conductors. The 30 mil PVC jacket is the same thickness of jacket that's used on an NM cable, and UL has determined that it provides an acceptable amount of separation between the power and the signal and control. So this has been recognized by UL and supported by UL. It's recognized in the NEC as an NEC compliant product. So we address the two major things, the separation and then the voltage rating. So this is used for, again, LED lighting is going to be the biggest use at this time for this product, where you supply a 0 to 10 volt dimming circuit in addition to your power circuit. So it's a jacketed pair. It's a blue jacket that'll provide the separation and the protection. And then you have 16 gauge TFN conductors that are purple and pink, are purple and gray. I'll talk more about that in a moment. Line voltage conductors are the standard products that we would have for MCAP cable. So standard THHN or XHHW conductors, and you can get any color combination in solid or stranded. And again, we can make customized versions just like with our other MC cable products, MCAP products. We can make variations on these for you. Now let's take a closer look at the MC-PCS Duo cable. This is our Southwire MC-PCS Duo product. This contains both the power wiring and the signal and control wiring that are useful for especially LED dimming type of applications. This cable is constructed in the same manner as our MCAP cable in that there is a full-size bare aluminum equipment grounding conductor. In addition, we have our phase and neutral conductors, and then we have this blue jacketed control cable with the individual purple and pink conductors as required by the 2020 NEC. This construction is also an MC-PCS Duo construction. Plus, it is designed for the healthcare facilities. So this incorporates characteristics of both products. So this has the MCAP style construction with the full-size aluminum equipment grounding conductor that will be cut off, even with the armor. And then we have our phase, neutral, and then redundant equipment grounding conductors as required for our healthcare facilities. In addition, we have the control cable that's going to be required for the LED lighting application. In this graphic, we'll take a look at two possible installation methods for LED lighting. In the first one, this is a code compliant but costly way to do it, where you have separate conduit or separate cables to handle the power and the control functionality. So this is going to provide the separation that's needed. These are listed products, but it's going to be an expensive way to do it, both in terms of material and labor. Well, here's another way to do it. We can take a single conduit or a type MC cable that has the class 1 circuit for lighting, the 600 volts, but then let's say it utilizes 600 volt conductors for a class 2 circuit, our listed class 2 cable, and then installs that within the same conduit or same MC cable. That may meet the 600 volt requirement for all conductors. Both of those individually may be listed. The problem is when you combine them together, they won't have the required separation that the NEC demands. So this is a potentially unsafe way to do the installation. It may be more efficient, but it's not code compliant. The best solution is going to be this MC-PCS type cable. This is going to give you the compliant 600 volts for the power and the lighting circuit, and in addition the other control and signal conductors. And those conductors are going to be encased in a 30 mil jacket that will provide the necessary separation. So this gives you efficiency, and this also gives you a very safe and code compliant installation. One final word about the control conductor colors. This is in regards to a change that occurred in the 2020 NEC. So NEC section 410.69, which addresses the identification of the control conductors, and this section was added, it's brand new in 2020. It disallows the use of colors reserved for grounded branch circuits, in other words, white or gray insulated conductors, and the equipment grounded conductor, which would be typically green in the circuit size products. So, in other words, it does not allow gray and purple to be used. The gray and purple colors were chosen by the lighting industry a long time ago for the control application. So the NEC wanted to address this by requiring that the gray conductor be changed to a different color. But in doing so, the NEC allows permanent re-identification of that gray conductor. So that way, cables, the older cables that were produced with purple and gray control conductors, they can still be used after January 1st of this year, 2022. So the intention was that the manufacturers would transition away from purple and pink conductors, from purple and gray conductors to purple and pink conductors by January 1st of this year. Southwire has done this. So any new product that we're producing, and hopefully at this point, most of the product that's available out in the field will have the purple and pink conductors. However, if you run across something that does have the purple and gray, you can still use that. You just have to permanently re-identify the gray conductor to indicate that it's not a neutral and it is in fact a control conductor. Thank you for joining us for these videos. This concludes the fourth video and the complete set of 4 videos regarding MCAP products. If you have further questions, you can reach out to us. Please check our website at southwire.com. Also, any technical questions can be addressed at this email address, CableTechSupport, altogether, CableTechSupport at southwire.com. Thank you.